हेलो दोस्तों, कैसे हैं आप। सो दोस्तों का टुडे वी आर गोइंग टू स्टार्ट विद वन मोर इम्पॉर्टेंट टॉपिक ऑफ क्लास 12th, application of derivative, and we have been solving questions from tangents and normal. Okay, and we have already solved around 21 questions from the tangents and normal application of derivative, and we will try to solve as many questions possible in uh, the same video. Okay, and thank you very much for joining this video, and let's start. And my name is Gaurav Tyagi. Thank you very much for your welcome to GRV classes. Okay. Welcome to GRV classes. My name is Gaurav Tyagi. Let's start. So guys, what we need to do in this question is find the equation of tangent and normal to the parabola. So we need to find the equation of tangent to the parabola, and parabola is also a curve, as we know, and be it the any curve. Okay, so we do not need to be worry about the type of curve we have. We just need to be we just need to apply the formula, apply the logic into the question, and we will get the answer irrespective of the type of curve that we have. Okay, so here in this case what we need to do is to first of all find the slope of the tangent line. Okay, and then we have point given to us, and we'll simply put the value into the given value into the equations of a line. Okay, so first of all find out the slope of the tangent to the curve. Okay, so let's have slope of tangent to the curve, that is dy by dx, or you can say f dash x. Okay, so here we have y square is equal to 4x given to us. Okay, so what do we do here is using the implicit differentiation. We'll simply use the implicit differentiation. Using implicit differentiation to get dy by dx. ठीक है, use implicit differentiation to get dy by dx. So implicit differentiation अगर यूज करते हैं तो dy by dx of y square is equal to dy by dx of 4x. Okay, and this will be 2y dy by dx, that will be equal to 4a. Okay, and we can solve it further. So dy by dx will be equal to 4a upon 2y. So that will be 2, so 2a upon y. So dy by dx is equal to 2a upon y. Okay, and here we have, so we need to find the value of the slope of the tangent at a particular point, which is dy by dx x is equal to 80 square. Okay, and that will be 2a upon y, because here we have we do not need to put the value of x here because x is not given here. We'll have to put the value of y, and the value of y is 280 as we know here, so we'll put 280. Okay, and on simplification what do we get from here is 2a will get cancelled out and we'll get 1 by t. So dy by dx is equal to 1 by t. Okay, and we need to find the equation of the tangent line, and in order to find the equation of a tangent line, what else we need to know is equation of a tangent line. We'll simply write equation of a tangent line y minus y naught mx minus x naught, and y minus y naught will be how much? Let's see. So x naught and y naught are given to us. These are the value of x naught and y naught. So this is x naught and y naught, and x naught and y naught are 80 square and 280. Okay, so substitute the value into it. So y minus 280, and that will be x minus x naught. Okay, so this is how we can solve. And so substitute the value into so try to simplify this further, and this will be yt minus 2a t square is equal to x minus a t square. Okay, so that will be yt minus x is equal to two at square. Okay, and from here we can take out we can simply take at square common, so that will be okay, so that is 2 plus 1 3 at square. Okay, so this is the required equation of tangent to the curve, that is the required equation of tangent to the curve. And in order to find the equation of normal to the curve, in order to find the equation of normal to the curve, so equation of y minus 1 minus 1 upon m x minus x naught, and where m is the slope of the tangent line, so the slope of the normal to the curve will be minus 1 upon m. Okay, and we'll substitute the value into it. Let's see how it goes. So y minus y naught, and y naught is, as we know, is 280 square 280 is equal to, so here m is equal to 1 upon t. So here, from here, slope of the normal to the curve will be minus t. Okay, so that will be minus t, and x minus 80 square. Okay, and we'll substitute, we'll solve this further. So y minus 280 is equal to minus xt plus at cube. Okay, and y plus xt is equal to 80 cube plus 280. Okay, and we can take something, we can take whatever is common. So y plus xt is equal to 80, we can take common from here, and here it will be 2 t square, and here it will be 2 only. Okay, so that is the required equation for normal to the curve, and the curve is given to us parabola. So parabola is given to us. Okay, so whatever is the curve, we do not need to be worried about the type of curve we have here. We just need to substitute the value and using use the formula. Okay, so these are the two equations that we got from for equation of tangent and equation of normal. Okay, and I hope you have understood this part. ठीक है. Okay, so guys, there is some so it was minus 80 square initially, and this was supposed to be 80 square only. This was supposed to be 80 square only, because minus plus will get cancelled out, and it will be 2 minus 1 is 1. Okay, so this is the answer. Okay, and please do make sure that you have done it correctly. Okay, and if you have any confusion in solving this type of questions, so please let me know. We'll try to solve it further, and we'll try to discuss whatever is not understood. Okay, so let me check for the sound. Okay, and we'll try to discuss whatever is not understood. Okay, so it is okay. The sound is perfectly fine. Okay, so let's see. Let's try to solve one more question from the same topic, and here we have proved that the curve this and this cut at a right angle if 8k square is equal to 1. Okay, and guys, as we know that tangents to the curve, okay, and tangents to the curve should be perpendicular to each other if the curves are cut at a right angle. Okay, so curves, if the cuts at a right angle, it means tangent at the point of intersection. The tangent at the point of intersection should be perpendicular to each other. Okay, if the curves cutting at right angle, then the tangents drawn at the point of intersection should be perpendicular to each other. So that is the concept we'll see. Okay, so we'll use that property, and before that, let's try to find out the slope of the tangent to the curves. Okay, so slope of the, okay, so guys, here we have some issues. So slope of the prove that the curves x is equal to y square and xy is equal to k. So guys, we need to be very careful in finding out that if the two curves are cutting each other at 90 degree or right angle, then the tangent at the point of intersection should be perpendicular to each other. The slope of the tangent line, we'll see. Slope of the tangent line is dy by dx, or you can say f dash x. Okay, and this for the first slope, for the first curve, for the curve x is equal to y square using implicit differentiation, to get dy by dx. So it will be d by dx of x, d by dx of y square. Okay, and this is 1 is equal to 2y dy by dx, or you can say dy by dx is equal to 1 upon 2y. Okay, so dy by dx is equal to 1 upon 2y, and what we need to do in this, to substitute the equation. Okay, and so this is the slope of the one of the tangent line, and let's try to find for the curve, for the curve xy is equal to k, for the curve xy is equal to k, using implicit differentiation, to get dy by dx. Okay, using implicit differentiation to get dy by dx, and well, what we do is dy dx of xy is equal to dy dx of k. Okay, and dy dx of xy is equal to dy dx of k, and in this we'll solve by using product rule. So dy dx of x, keeping y as it is, dy dx of y, keeping x as it is equal to 0, because dy dx of k, or differentiation of constant, is 0. So from here what we get is y plus dy dx x is equal to 0, and if we substitute solve it further, so it will be dy by dx is equal to minus y upon x. Okay, so dy by dx is equal to minus y upon x, and here we get dy dx is equal to (1 upon 2y). So these are the two equations that we got. So prove that the curves x is equal to y square and xy is equal to k cut at right angle if 8k square is equal to 1. ठीक है, तो इसमें क्या कर सकते हैं हम, dy by dx is equal to 1 upon 2y and dy by dx is equal to minus y upon x. Okay, so these two should be perpendicular to each other. Okay, so these two should be perpendicular to each other, and the curve, if the slope of these two are perpendicular, if these two tangents are perpendicular to each other, then their slope should be, so if it is m1, okay, so if it is m1 and if it is m2, ठीक है, for the slope of the line perpendicular to each other are m1 m2 is equal to minus 1. Okay, so we'll substitute that 1 by 2y into minus y upon x, that should be minus 1, and from here as we see, this will get cancelled out, and we will have minus 1 by 2x is equal to minus 1, so 2x is equal to 1. Okay, so we get 2x is equal to 1 from here. ठीक है, and 2x is equal to 1. So guys, what we need to do in this case here, in this case what we need to do is to get the value in terms of k only. Okay, so get the value in terms of k, and we can solve these equations. Okay, so solving equations, let's write it down here. To get the point of intersection, x is equal to y square and xy is equal to k. So x is equal to, solving x is equal to y square and xy is equal to k to get the point of intersection. ठीक है, तो इसमें क्या करना है, x की जगह y स्क्वायर रख दो, और यू कैन से y की जगह k बाई x रख दो. सो x इज इक्वल टू, और यहाँ पर y की जगह सब्स्टिट्यूट कर दो, y इज इक्वल टू k बाई x, तो y इज इक्वल टू k बाई x स्क्वायर. ओके, एंड सॉल्विंग इट फर्दर विल रिजल्ट इनटू x cube is equal to k square, and solving it further will result into k की power 2 by 3. ठीक है, so k की power 2 by 3 is the result here, and this is the equation 3. ठीक है, and we can write it down like this is the result that we got, and now further we can substitute the value into this. Okay, so let it be equation 4. So using equation 3 and 4, we get, so here x is equal to k to the power 2 by 3. So 2 into x is k to the power 2 by 3 is equal to 1. Okay, and we can simply cubing both sides. So take cube of the equations both sides, cube of the, taking cube of the above equation, so it will be 8 k square is equal to 1, and that this is what we were supposed to find out. This is what we were supposed to find out. Okay, so we got it. Okay, and 8k square is equal to 1, taking cube of the above equation, and this is how we can solve. Okay, so guys, you need to be very careful in finding out what are we supposed to find. So when the two curves are perpendicular to each other, so the tangents at the curves, tangent to the curve at the point of intersection should be perpendicular to each other. So we have not written that line, but we should write it somewhere. Okay, so we can write it just below it. So when two curves are intersecting, or you can say cut at right angle, the tangents drawn at the point of intersection, the tangent drawn at the point of intersection are perpendicular to each other. Okay, so this is the required theorem or required process concept that we have used in this equation, used in this question. So guys, let's try to solve one more question from the same topic, and before I start solving, let's So guys, let's continue. Welcome back to your favorite YouTube channel GRV classes, and my name is Gaurav Jai. So what we need to do in this case is, we need to find the equation of the tangent and normal to the hyperbola. Okay, so this is the equation of the hyperbola, and in order to find the tangent to the curve, whatever the type of it may, whatever the curve it may be, so we need to apply the same rule. Like first of all, we need to find the slope of the tangent line and then put that into the equation of a line. Okay, so slope of the tangent to the hyperbola we'll simply write down slope of the tangent to the hyperbola is equal to dy by dx or f dash x. ठीक है, and the curve is, this is not an explicit equation, so we'll use the implicit differentiation. Using implicit differentiation, to get dy upon dx, and here we have dy by dx of x square by a square y square by b square is equal to dy by dx of 1. Okay, and dy by dx of 2x upon a square minus 2y upon b square into dy by dx is equal to 0. So here it will be dy by dx is equal to 2x upon a square into b square upon 2y. This will be 2. Okay, and that will be b square upon a square into y. ठीक है, and b square a square, b square upon a square y. So this is the slope of the tangent to the hyperbola, and we need to find the equation of tangent to the hyperbola. Equation of tangent to the hyperbola, as we know, will be equal to y minus y naught mx minus x naught. Okay, and y minus y naught is equal to mx minus x naught, so that will be y minus, as the point are known to us, so this is x naught and y naught only. Okay, and we'll substitute the value into it, and that will be y minus y naught is equal to b square a square y naught. Okay, so y will be y naught because the point is y naught here, and here we will have x minus x naught. Okay, and if you solve this further, so this will be y minus y naught a square y naught y minus a square y naught square is equal to b square x minus b square x naught. And if we take it, if we simplify it further, so that will be a square y naught y minus b square x is equal to b square x naught plus a square y naught square. Okay, and that is how we can we get to the conclusion, we get to the equation of the tangent to the hyperbola. Okay, and so let's try to find out the equation of normal to the hyperbola. So equation of normal to the hyperbola will be y minus y naught minus 1 upon m x minus x naught. ठीक है, so y minus y naught is equal to minus 1 upon m x minus x naught, so that will be y minus y naught. ठीक है, so that will be y minus y naught. So minus 1 upon m, so we'll, as we know, the m is b square upon a square y, so we'll get m minus 1 upon m will be a square y naught b square minus y minus a square y naught upon b square, and here it will be x minus x naught. Okay, and if you solve it further, so that will be b square y minus b square y naught is equal to minus a square y naught x plus a square y naught x naught. Okay, and let's simplify it further. So that will be b square y plus a square y naught x is equal to b square y naught plus a square y naught x naught. Okay, and that is how we can solve this type of questions. So this is the required answer, and if you have any difficulty in solving this type of questions, so please let me know, guys. So answer to the v square x naught upon a square. Okay, so there's one more part missing here again. Sorry for that. It's x is missing from here, so this is xb square. Okay, and that will be x square, so b square x naught e square. Okay, and similarly in the case of hyperbola, so that will be x naught here, b square x naught, and that will be x naught, so, and this will be x naught. Okay, so b square y x naught, and this will be b square y naught x naught. Okay, this is how it will be. So b square x naught y minus y naught minus a square y naught x minus x naught. Okay, so this is how we can solve, and we can solve it further as well. Like we can take b square x naught common from here, b square x naught. Okay, So we can take b square x naught common from here, and that will be y minus y naught, and it will be, we can take a square y naught common from here, so a square y naught, and that will be x minus x plus x naught, or you can simply write down x minus x naught if you take minus common outside the bracket. Okay, and if you try to like divide it by b square x naught or a square y naught, so that will be b square, okay, y minus y naught upon a square y naught plus x minus x naught is equal to 0. Okay, so that may be the required equation. That may be the required equation. You can solve this way as well. Okay, guys. So this is how we can solve this as well, and this might be the one of the answer. Okay, so you can simplify it further, and let's try to solve one more question from the same topic. Find the equation of tangent to the curve. Find the equation of tangent to the curve which is parallel to line this. So when the guys, as we know, when the two lines are parallel, they have the slope equal. Okay, so when the two lines are parallel to each other, they have their slope equal. Okay, so we'll use that property. Slope of the tangent to the curve y is equal to under root 3x minus 2 is dy by dx, or you can say f dash x if it is written in the form of fx. So dy by dx is equal to d by dx of 3x minus 2, okay, which will be 1 by 2 under root 3x minus 2, and d by dx of 3x minus 2 is 3. Okay, so that will be 3 by 2 under root 3x minus 2. Okay, and the slope should be equal to the slope of the since the tangent line is parallel to the given line, है so slope of this parallel line will be equal to the slope of the tangent line. Okay, so comparing the given comparing 4x minus 2y plus 5 is equal to 0 with y is equal to mx plus c, which is a slope intercept form. Okay, and in order to compare this, so we have to take y is equal to 4x plus 5 upon 2, and that will be 2x plus 5 by 2, and if we compare this equation with y is equal to mx plus c, so we get m is equal to 2. Okay, and this is the first equation. Okay, so this is the first equation, slope of the tangent to the curve, and this is the second equation, slope of the parallel line to the tangent line. Okay, so these two should be equal. So using equation first and 2, we get three by 2 under root 3x minus 2 is equal to 2. Okay, and we'll take squaring both side. We'll see squaring both side. Squaring both sides will give us 9 is equal to 4 3x minus 2 square, or we can simply write down this is 3 square. Okay, this will go to other side 4 and under root 3x minus 2. Okay, and when we square it, so it will be 9 is equal to 16 3x minus 2, and if we solve it further, so that will be 9 by 16 is equal to 3x minus 2, and 3x will be equal to 9 by 16 plus 2, and if we solve this, so that will result into 16 2 the 32, 32 plus 9 is how much? 32 plus 9 is 41, 41 upon 16. ठीक है, and x as we get is 41 upon 48. ठीक है, that is the value of x. Okay, so find the equation of the tangent to the curve. Okay, so we get x is equal to 41 by 8, and the y will be equal to under root 3, and in place of x will substitute 41 by 48, and that will gives us y is equal to, so this will get cancelled out, it will be 16, 16 minus 16 is 32, 32 41 minus 32 is 9, 9 upon 16, so that will be 3 by 4. So y is equal to 3 by 4. Okay, and here we get the point, x is equal to x naught, y naught is equal to 41 by 48, and here we have 3 by 4. Okay, and what we need to do is find the equation of the tangent line. So equation of the tangent line, is y minus y naught m x minus x naught. ठीक है, and m as we have calculated is 2. Okay, so here we get y minus y naught as well, so y minus 3 by 4 is equal to 2 x minus 41 upon 48. Okay, solving it further, that will result into 4y minus 3 upon 4, 2x minus 41 upon 24. Okay, and we can simply write it down. Okay, so we can cross multiply this further and get the answer. So 4y minus 3 is equal to 8x minus 41 by 6. Okay, so 4y minus 8x is equal to 3 minus 41 by 6, and solving it further will result into 4y minus 8x will be equal to 18. So 41 minus 18 is how much? It will be 41 minus 18 is how much? So 18, and it will be 23. 23 plus 8 is 31, 41. Okay, 23 upon 6, and that will be of minus. Solving it further, 24y minus 48x plus 23 is equal to 0. That is the required equation for tangent to the equation of tangent to the curve. That is the required equation of tangent to the curve. ठीक है. because we cannot take common from all the terms. Okay, -48 minus 14 24 y is equal to 23. Okay, that is the correct. So which is the required equation? Okay, and guys, if you have any difficulty in solving this type of question, so please let me know, we can discuss whatever is not understood. Okay, and I hope you have got the idea of it. Okay, so we have not again mentioned the concept that we have used here. So concept is, guys, when the two lines are parallel to each other, their slopes are equal. So we'll simply write out the note before the so this is the note. When two lines are parallel to each other, their slopes are equal. Their slopes are equal. Okay, so this is the important concept that we need to remember in order to solve this type of question. So guys, let's have one more question from the same topic. The slope of normal to the curve is given to us, and we need to find out which one is the correct. Okay, slope of normal to the curve. Okay, so first of all, find out the slope of tangent to the curve. Slope of tangent to the curve y is equal to 2x square plus 3 is dy by dx, or you can simply write f dash x, and dy by dx is equal to dy by dx of 2x square plus 3, and that will be equal to 4x only. Okay, and dy by dx at x is equal to 0. Okay, that is 3 sin x, so we should not miss it, guys, should not miss it. So that is 3 sin x, and here we have sin x as well. So 4x plus 3 cos x, and dy by dx at x is equal to 0, that will be 4 into 0 into 3 plus 3 cos 0, and cos 0 is 1, so that will be 3 only. So dy by dx at x is equal to 0 is 3. Okay, so slope of normal to the curve, we'll see slope of normal to the curve. If it is m, so slope of normal to the curve is equal to minus 1 upon m, and m we have already known to us, m is already known to us. So if it is slope of normal to the curve, if it is m2, and if this is m1, so this is m1, so m2 will be equal to minus 1 upon 3. Okay, so slope of normal to the curve is minus 1 upon 3, and that we were supposed to find out. That is what we were supposed to find out. So correct answer will be equal to m2 is equal to minus 1 by 3. So D is the correct answer here. Okay, and I hope you have understood. So here we have one more question of the similar type. The line y is equal to x plus 1 is a tangent to the curve. The line y is equal to x plus 1 is a tangent to the curve at the point. Okay, so we need to find the point here. Tangent to the curve is given to us. Okay, so what we do here is equating or comparing the given equation, comparing the equation of tangent line with y is equal to mx plus c, that is slope intercept form. slope intercept form. So y is equal to x plus 1 and y is equal to mx plus c. So from here y is equal to 1, sorry, m is equal to 1. ठीक है, so that is slope of the tangent to the curve. So slope of tangent to the curve, slope of tangent to the curve y square is equal to 4x is dy by dx. ठीक है, और dy by dx निकालते हैं यहाँ पर, देखो दोस्तों. So dy by dx is equal to dy by dx is equal to dy by dx of, okay, so this is implicit differentiation. We'll use the implicit differentiation because y square is given here. Using the implicit differentiation, to get dy by dx, so dy by so this will be dy by dx of y square is equal to dy by dx of x. Okay, so that will be 2y dy by dx is equal to 1. So dy by dx will be equal to 1 upon 2y. Okay, and from the above equations we get y is equal to sorry, m is equal to 1. So this is the first equation. Okay, so this is the first equation here, and this is the second equation. ठीक है, and from equation first and 2 we get, from equation first and 2 what do we get is, from equation first and 2 we get 1 upon 2y is equal to 1. Okay, and solving this further will result into 2y is equal to 1 or y is equal to 1 by 2. ठीक है, from there we get y is equal to 1 by 2. ठीक है, substituting the value into equation of a curve. कर्व की इक्वेशन हमें क्या दे रखी है, देखो y स्क्वायर इज इक्वल टू 4x. सो y स्क्वायर इज इक्वल टू 4x. y स्क्वायर इज इक्वल टू 4x. तो यहाँ पर y की जगह रख देंगे 1/2. 1/2 स्क्वायर इज इक्वल टू 4x. सो 4 इट विल बी 1/4 इंटू 4x. ठीक है, सो x विल बी इक्वल टू 1/16. ठीक है, so x will be equal to 1/16. So the point that we were supposed to find, where the line equation, the line is a tangent line, so these 2 points are x is equal to 1/16 and y is equal to 1/2. Okay, so x is equal to 1/16, y is equal to 1/2. Okay, here we get m is equal to 1, then 2y dy by dx is equal to 4. Silly mistake again, guys. Here we have 4 and this will be 4, and this will be 2 upon y. So 4 upon 2y, that will be 2 upon y. Okay, and from here we get 2 upon y is equal to 1. From here we get 2 upon y is equal to 1. So 2 upon y is equal to 1, so y is equal to 2. And y is equal to 2 will give us y is equal to 2 will give us 4, x is equal to 1. ठीक है, so x will be 1. ठीक है, so x will be 1 only. ठीक है, so x is 1. And from here we get points x is equal to 1, y is equal to 2. So from here we can see that x is equal to 1 and y is equal to 2 is the right answer. Okay, and we can like solve it completely again, like we can solve it completely again this way. Okay, is there any need to solve it further? Okay, let's see. So that is y square is equal to d by dx of y square is equal to d by dx of 4x. So dy dx of y square is equal to dy dx of 4x. Okay, so dy dx of y square is equal to dy dx of 4x, and that will result into 2y. dy by dx is equal to 4, and from here we get dy by dx is equal to 4 upon 2y, that is 2 upon y. ठीक है, and dy by dx is equal to 2 upon y. So we'll say this is the second equation. Okay, and we can simply write down here, comparing equation from equation 1 and 2, we get from equation 1 and 2 we get 2 upon y is equal to 1, hence y is equal to 2. ठीक है, substituting the value of y into the into y square is equal to 4x, so that will result into 2 square into 4x, and from here we get x is equal to 1. So the point are 1 and 2. Okay, so this is how we can solve, and the point are 1 and 2. Okay, so this is how we can solve this type of questions. And guys, if you have any difficulty in solving this type of questions, so please let me know in the comment box. And thank you very much for taking your time and learning this part, and we'll meet you soon. So have a nice day, take care, bye bye, see you.